All right, everyone, today we're going to take a look at graphing inequalities and graphing functions and quadratics. Okay, so let's take a look at the first two on the packet for today. So we have the function 6 minus 5x minus 3x squared. So I've gone ahead and graphed that in a graph window in my GDC. If we notice over here on the right, the window is not set to the sort of standard GDC window. So I'm just going to come over here, and where this says text, I'll double click on that, and then I can just get my window on my GDC to match the window that is on my worksheet. Okay, so double click on all of these. That one says 10, and this one is 4. Or sorry, this one's 1. Okay, so that is what my GDC now looks like. So I've gone ahead and done a very quick sketch on my worksheet here. Okay, so next thing this asked me to do is write down the y-coordinate of the point where the graph crosses the y-axis. Now I know my y-axis is my horizontal axis, so anytime we are crossing that horizontal axis, my value for x is 0. So when I'm trying to figure this out, I'm really trying to figure out what is f of 0. Well, f of 0 would be 6 minus 5 times 0 minus 3 times 0 squared, right? Okay, so this term is going to go away, okay, 0, and that'll be 0 as well. All right, so I'll be left with 6. Okay, so the answer would be y is equal to 6. Okay, part C, write down the x-coordinates of the points where the graph crosses the x-axis. Okay, x-axis is my horizontal axis. All right, so the x-coordinates, okay, we can do that by coming over to our GDC. We're going to click on Menu. I'll go Analyze Graph, and I'm going to click on 0. All right, it says lower bound, so I just need to click somewhere to the left of whatever I can see I have a root here or a 0. Okay, so I'm going to click somewhere to the left of that, and then down here it's going to change to upper bound. So I'm just going to drag over, and I'll notice that it'll give me that point there. Okay, so the first x value is going to be negative 2.47. Okay. But we can see over here I have another 0 or another root. Okay, so I'm going to do the same thing. Menu, Analyze Graph, 0, lower bound, upper bound, okay, and 0.81 will be my next x value. All right. Part D, you find the x-coordinate of the local maximum point. The local maximum for this parabola is going to be the vertex, right? So I can find that, again, using my GDC, coming over here to Menu, Analyze Graph, and I'll click here on Maximum. Okay. Again, it's going to say lower bound, so I just need to, I can see my vertex is somewhere around here, right? So I'm just going to click to the left of that vertex. Again, this is going to change to upper bound once I click on that, and I'll just drag over until I know that I've sort of encompassed my vertex in that shaded region. Okay, and it says the coordinates of that maximum point, so that's going to be negative 0.83, repeating. Okay, and then 8.083 repeating. Okay, I'm just using this value that my GDC gives me. Okay, now it gives us another function, g of x. So on the same diagram, sketch the graph of y equals g of x. So if I come over here to my GDC and click on tab, again, that'll open up a new function line for me. So I can input 2x plus 4, hit enter. All right, and I get my second function here. So we can go ahead and give that a sketch, something like that. Okay. And then, so it asked me to find the coordinates of the points of intersection of f of x and g of x. So that's going to be that intersection point and that intersection point there and there, right? So we come over here to our GDCs, and I'm going to hit Menu, Analyze Graph again, and this time number 4, intersection. Okay, so again, it's asking for lower bounds and upper bounds, so I see my intersection point here, so I'll click to the left of it, drag over, click to the right, Okay, and I get negative 2.59, okay, and negative 1.18. Okay, but I have another intersection point here to the right, so I'm going to do the same thing. Menu, analyze graph, intersection. Click once, drag over, click again, and I see here that I have another intersection point at 0.26, comma 4.51. Okay, so those are some of the tools and functions that we're using in our TI Nspire to graph and analyze quadratics.